Welcome back to my channel. Today we will discuss push-pull converter topology. In high power SMPS designs, when we need above than 500 watts power output, at that time this topology is used. What is in this design? It uses a center taped transformer. Push-pull transformer have center taped transformer in primary and in secondary. And the unique thing in this transformer that this dot is here, this dot is here, this dot is here, and this dot is here. Positive voltage will applied here at this point, and we have one switch here and the second switch here. These two are connected to ground. One diode is here. Then there is inductor, positive, negative. This is capacitor. And here is RL. The second diode here. So this is a push-pull converter topology. It can use transistor, it can use MOSFETs, IGBTs. How it works? This is Q1, this is Q2. In the first half cycle, when Q1 will turn on, in this period current will flow from this switch to the transformer winding. So this end is positive, winding this end will become negative. As this dot is opposite side here, this end will become negative, winding this end will become positive. So the condition here that the same voltage will reach in this winding and this winding will behave like this. This end is negative, positive. At that time, winding this end is positive and this end will become now negative. We are allowing current here in this winding, but that time this transistor will receive, these are positive voltage, battery voltage. Positive, negative, positive, negative. So if we see from this end, positive, and we have same amount of voltage in this winding, so this transistor will receive double voltage stress. When Q1 is on, Q2 will receive 2V in. If we are applying 300 volt here, this transistor will receive 600 volt. Double voltage to the applied voltage. If we see here, this is T1, Q1 PWM signal. When it is powered on at that time, VDS1 will drop because it will saturate and it will allow to flow the current. But that time, this VDS2, this portion is receiving double voltage. 2V in. Here is V, the applied voltage, but at that time this transistor will receive 2V in, Q2, VDS2, voltage drain to source 2. When Q1 is on, this end is positive, same time winding this end is positive, this end negative, this end positive, this end negative. In this Q1 turn on time, this diode is forward bias. When it is forward bias, it will allow to flow the current. The voltage induced, which are reflected from this primary winding into secondary due to mutual induction. So current will flow from this diode to the coil, to the capacitor and the load. So the current will start to increase linearly, IL1. it will increase linearly. Why? Because the inductor will provide inductive reactance, so it will cause to increase a linear current increase. Now when the first switch will turn off, after that a small amount of time is allocated, that is called as a dead time. After T1 on, in T1 on, IQ1 will increase linearly. Why? Because this winding it have inductive reactance. Now when this time will arrive, at that time this magnetic field will collapse. When it will collapse, it will create oscillation effect. Why? Because there is a dead time. So this oscillation will reach at this transistor. There is a recovery diode in parallel, so this leakage inductance will grounded from this diode. In the off time, this off time, when this winding is off, the core magnetic field will collapse and inductor magnetic field will collapse. Before this end was positive, this end is negative. When its magnetic field will collapse, what will happen now? This end will become negative, this end will become positive. At that time, we can see this diode is now forward bias, but here the magnetic field position is changed. And if we see this diode, before this diode was negative, now it will become positive. This end will become positive. When it will become positive, at that time it will discharge this inductor. So the inductor magnetic field will become zero. When it will demagnetize, it will become ready. So it is the function of dead time between two channels. Then the Q2 will turn on, this one. When this will turn on the same way, when it will close, the current will flow from this side. In this portion, the current was flowing in this side, but now the current polarity will reverse. Why? Because we have center taped winding. When this end will become negative, at that time this end will become negative and this end will become positive. Before this, when it was working, the double voltage stress was here, but when it will turn on, the voltage stress will reach at Q1. When this Q2 will turn on, it will receive V in. At that time, the Q1 will receive double voltage stress in this period. Now, winding this end will become negative, this end positive. When this end is positive, same time this end is positive. And if we see now this dot side, if we see this dot side, this end will become negative and this dot side will become negative and this end will become now positive. So this diode will become forward bias. In the first half, the current was flowing from this diode to the load and this portion, but now the current will flow from this diode, inductor, capacitor and RL to the winding this end. At that time, this diode will work. IQ2 will increase linearly. Why? Because transformer have primary winding inductive reactance, and the same time the current which is flowing in the secondary in the load side, it will also reflect the load current on this transistor. So current will increase linearly. Same way in this off period, that is called dead time. At dead time, the inductor core will discharge through this diode from the opposite side, and the same way we have recovery diodes across these switches. When this transistor will turn off, at that time the leakage inductance spike will discharge through its diode. So the transformer magnetic field will swing in both directions because its current will flow in both directions in one cycle. In half cycle the current will flow in this direction, in the second time the current will flow in this direction. So the magnetic field polarity will change 2 times in one cycle. In half cycle, magnetic field in this way, second time in this way. So magnetic field will swing north to south, south to north 2 times in one cycle. So that is reason it is called bipolar magnet or bipolar switching. When Q2 is on, at that time the inductor current will increase linearly because inductor have inductive reactance. The same way it will discharge through this diode. So the important things here that when one transistor will turn on, the second will receive double voltage stress. It is called hard switching. This is the drawback of this push-pull converter. Second thing, the transformer is center taped here and here. So its magnetic field will bipolar. Most of the time it is used in solar inverters when we have low voltage and we need high power output. At that time this topology is used because this topology provides 2 times switching in one cycle. When we were discussing unipolar, that are flyback, forward converters, boost converters, that converters switch 1 time in one cycle. That converters switch half period, and half period is allocated to demagnetize the core. But here in this topology we need 2 times switching in one cycle. From here to here we have 1 cycle. This is 1 cycle. So in one cycle we receive 2 times switching. When we receive 2 times switching, that means we will receive low output ripples in the output. This is the benefit of this switching, and it provides high output power. I hope this video is informative. If it is informative, hit the like button. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.